With intuition, we can all figure out that we need trees in urban areas to lower the heat during the summertime. It's really hot right now, but not everyone has the privilege to live in areas that has a high coverage of trees, right? This is like comparing Sandton and Ivory, where I'm from. If you are not from SA, I'm sure you'll understand what Sandton is. This is the high suburban towns that we have out here. So this is redesigning the world. Trees we should plant so that we reduce heat in urban area. So the relationship between heat and human mortality rates is what led me to this study, to actually try and research what we have to do to actually lower the temperatures around here. Obviously causes that increases this heat, not just summer heat. Climate change is one of them. We understand this. Some of these problems are problems we've tackled in other videos, such as urbanization, pollution, overpopulation, and industrialization. Of course, there's way more such things as air conditioning. It's actually removing heat from the house and taking it outside, so people who are living in the other side and don't have the privileges of owning air conditioning get affected by people that own air conditioning. So summer air temperatures will continue to rise, as mentioned. So this will intensify daytime and nighttime air temperatures and resulting in thermal discomfort. Most urban areas have low albedo. So albedo are like dark surfaces, so that during daytime they actually absorb shortwave radiation and is re-emitted at night, re-emitted as long wave radiation, and it heats up the city even more. So like it's way hotter than it's supposed to be. Trees, they cool air and surface temperatures like through transpiration. So this is a process that regulates by cooling air around the leaf by releasing water, and it cools down the air around. Whereas there's canopy. Canopy is like the coverage of the tree. It reflects solar radiation, providing shades and blocking light transmission through the crown of the tree, right? And preventing solar radiation to be absorbed and re-emitted, as we've discussed already. So it's something that I think we'll talk about the most in this video, because the study that I read, they focused on it the most. So like what type of trees should be planted so that we can get the best canopy, so we reduce air temperatures in urban areas. So canopy properties like that prevent light transmission to provide quality shade. It depends on the positioning of the leaf and foliage density. So how separate are the branches and how leaves actually positioned within a tree. This determines the density of this canopy, like the type of quality that we should have. We'll understand canopy more and more as this video proceeds, right? So daytime cooling benefits of the trees keeps improving as canopy cover increases, and since this is reflecting solar radiation and providing more shade, and the transpiring of water is generating more transpirative cooling, the tree covers a large area, it provides a large shading. This transpiration, there's this thing that we always talk about. If you go through the channel, we'll find it. The temperature between a shade and when you're outside of the shade is the same, but with certain trees that have high canopy density, the temperature is different because there's already cooling by water from the tree. So other facts we should look at when we're planting these trees now is size of the tree. So tall trees, wider trees, they create more shade and resulting in a more efficient cooling for the urban areas. So when we're talking about the good that these trees are bringing to urban areas, we have to also talk about the negatives. Temperatures that have been increased due to this high canopy density during the day, when compared to the night, they increased from 21 degrees Celsius to 24 or 28 to 30, like compared to other areas that don't have this high canopy density, right? So nighttime thermal conditioning is very important for human beings, so that we relieve the heat that we we consume heat. The heat that we consumed during the day, if like it's highly elevated, we have to reduce them and relieve them during the night. That's why we have to have colder nights than warmer days. The study that I read from the University of Western Sydney shows that the type of trees that were planted around like a certain area, and they studied how these trees are going to benefit the cooling of temperature around the area. So like we have multiple tree species, and we see that these type of trees have like different canopy covers than others, right? So we see how they benefited. So if you're trying to plant like trees in urban areas, you have to look at these types of trees or species so that you know which one is best based on its canopy density. We move on to another table now. This is tree height. It's very interesting because they picked these three. I don't know, it's a very complicated table. They compared three types of height trees, right, with less than 10 meters to 20 meters, and then the other one is less than 20 or greater than 20 meters. So we can see that during the day, these that have like high canopy densities, they really reduce daytime heating. But when we go back to nighttime, the nighttime is the below one. The ones that actually were reducing more heat during the day, they produce more heat at night. So we have to be careful on where we have to plant these trees. And the last piece of result that I'm going to talk about is this canopy density. It's another graph. This next graph, they grouped three types of trees that they usually plant together and saw how they performed under these circumstances, right? So we can even tell tree height and canopy density have the same type of effect. You can see that they reduce a lot of heat during the day and then they produce heat at night. So I have to be careful on which types of trees we plant, because they can be beneficial during the day and then be a negative during the night. From these studies we can figure out what type of trees we should plant and where. Short trees are closer to the sunlit surfaces that may be radiating heat, right? So if like this short tree has a high canopy and it's close to a surface that's radiating heat during the day, it's going to actually increase that heat based on what? Because the heat can't escape, right? So this is a benefit of low canopy density. The particular thing that I want to specify in here is that nothing is really like good per se, right? So high canopy is not good, low canopy is not good either, but if you know where to plant them, you're going to get good results. So we can plant these trees in spaces with low radiating surfaces like grass areas, in parks or other places that don't have low albedo surfaces. So let's take it like this. If you have a tall and a high dense canopy density, right, the sun radiations don't have the chance to actually reach the ground and be absorbed by dark surfaces. So you have to plant tall and high canopy density trees in the streets, right? So this is going to provide the best benefits of both. The large and dense canopy in the streets is sufficient to limit the absorption of shortwave radiation by the solar radiations, right? So this is going to prevent these shortwave radiation to reach the surfaces and be re-emitted as long wave, thus not cooling the night, right? So if the shortwave radiation doesn't reach the surface, it doesn't get re-emitted. So this is beneficial to plant in the streets. So you have to plant it where there's hard surfaces, tall but high density canopy. Then low canopy covers. So these can be short or tall trees, but they have like a lower canopy density or cover. It's more beneficial during the nighttime because when the heat is re-emitted, the heat that was already absorbed during the day gets dissipated quickly because there's more space to move around, right? So there's more air movement. So out of all this study, it got me thinking that maybe we should redesign the world, looking at neighborhoods such as where there are no trees, there's nothing. So we have to think about what type of trees, where should we plant all these type of trees, because people will be telling us we need more trees, but they don't do more research on how to plant trees. That's why they plant these type of trees. It's like a short tree, but they just planted it next to a street, so it really doesn't do anything. It got me thinking because it's crazy how 40% of canopy cover is needed for a neighborhood to get full benefits of these trees, but most suburbs have like less than 20% canopy cover and we have less than 10 is like being generous if you comparing Satin to Ivory, right? So we have to think about these things and how can we plant them so that they benefit everyone.